Hello, and thanks for joining this presentation titled Ambient Sample Capture Apparatus Provides VOC Speciation Using Next-Generation Air Monitoring Networks. I'm Ken McGary, co-founder and Chief Technical Officer of APIS US Incorporated, and I'm glad to share with you some interesting results from a new project we've been working on in collaboration with our environmental consulting partner, Ajax Analytics in Fort Collins, Colorado. APIS has been making criteria gas monitors for a few years now and have a solid remote air pollution sensing hardware and firmware platform coupled with a robust cloud backend and a no-muss, no-fuss, all-inclusive data-as-a-service business model that provides reliable, real-time, actionable air quality information for a reasonable cost. APIS gas monitors are designed from the ground up to provide a comfy home for best-of-class gas sensors. Criteria gases are detected by AlphaSense B4 series electrochemical sensors that are placed on a manifold with a steady flow rate to ensure best responsiveness. The actively aspirated radiation shield integral to the enclosure helps keep the sensors as cool as possible, and the power supply can take most whatever you throw at it, with active current limiting, power switch circuit breaker, and wide DC input voltage range. And it communicates reliably anywhere in the world with GPS receiver, 4G 2G cell modem, and Ethernet option as well. More recently, we've been adding an Ion Science PID sensor to our monitors for total VOC coverage as well. This optical-based sensor is super sensitive to low ppb levels and can detect many hundreds of different compounds at various sensitivities and response rates, but sadly cannot distinguish between them. Competing technologies also have their shortfalls. Complex, expensive analyzers like cavity ring-down spectroscopy and so on can perform detection miracles, but are expensive to buy and maintain. Low-cost sensors can provide interesting trend data, but what was in that big plume we just detected anyway? Manual grab sampling is fine for background levels, but mostly useless for detecting brief and/or unanticipated events. Our existing products and networks, shown here on the left, do a great job of collecting and fusing sensor data from a wide variety of sources, including gas, wind, particulate sensors, local AQS data, and more into an easy-to-use dashboard and easy-to-access data repository. This is just great for detecting trends and events, but how to speciate VOCs or even particulates once you know they are present? Last year, Ajax was our first customer for a new product that bridges this gap, providing sensor-triggered subatmospheric canister capture for lab analysis. This system is also capable of triggering other traditional speciation methods, such as a high-volume PM sampler. The APIS remote gas sampler provides solenoid valve control and continuous canister vacuum feedback for remotely controlled canisters. All internal wetted surfaces are stainless steel or fluoropolymers, providing excellent sample integrity. Common methods and procedures are supported, and sample gathering methods include grab, building, and integrating. Simple threshold triggers are controlled directly by sensor hardware and provide sub-second triggering latency. More complex triggers can be sent via API commands with a maximum 15-second delay. Our partner, Ajax Analytics, uses APIS technologies in their full-service environmental monitoring solution. Ajax provides a turnkey service that monitors an industrial concern and then aggregates multiple data elements to inform their customers of the real impact of the concern site on the local environment. We like to say that Ajax takes the excellent data that APIS provides and adds in scientific and analysis magic to develop the information that's useful to the end consumer. The city and county of Broomfield engaged Ajax to monitor large new oil and gas developments within their dense urban community of about 100,000 people. The goal of the community monitoring program was to find and quantify pollution releases and help Broomfield identify whether the new oil and gas development was the source. In order to build context for concerned citizens, Broomfield wanted the data to be compared to standard health guidelines for particulates and other air toxics such as benzene, a known carcinogen and deep concern in the community. All the real-time data and contextual reports are provided to the public through Ajax's web application, the APIS web portal, and regular impact reports. Ajax partnered with APIS and Colorado State University to execute a multifaceted air monitoring program that monitors air toxics and criteria pollutants near the oil and gas development sites, and also through the nearby neighborhoods, parks, and schools. The core philosophy behind Ajax's program designs is to maximize the balance of cost, time coverage, spatial coverage, and reference grade data. This resulted in a network of 20 monitoring sites throughout the city at a cost equivalent to running 1 or 2 traditional shelter-based monitoring stations. This dense network allows for amazing visibility into where pollution comes from in the city and how plumes move and disperse at a hyper-local level. The project also includes a number of technologies that are complementary to the APIS network. This includes trailer-based mass spectroscopy, a mobile plume tracker, weekly whole canister sampling. This enables some quite useful co-location metrics and support for the findings from each technology in play. Here is one example of a significant plume that was captured with the APIS system about 300 feet away from an active oil and gas site. This particular site had 2 APIS systems. As another example, Ajax was able to co-locate an APIS system with a trailer-based gas chromatograph in a near oil and gas site environment. Comparison of the GZ results with the APIS VOC trace showed remarkable synergy between measurements. Triggered canister samples highlight the challenges with knowing exactly how intense a plume is with technology that can only provide data at a 45-minute average time resolution. During the largest event, the GC measured benzene at 1.5 parts per billion, while the APIS system's higher temporal resolution was able to capture the peak benzene level of 30 parts per billion. In another program, Ajax was able to compare the efficiency of measurements using 24-hour integrated canister samples, a 15-minute mobile GC system, manual grab canister samples using a cavity ring-down instrumented vehicle, and a network of APIS PID sensors with auto-sampling systems. This bubble chart illustrates the efficiency of the APIS system. The most expensive part of a sampling campaign is the speciated reference grade measurement. Now, we're able to laser focus those costs on the moments that matter. The APIS triggered canister method also vastly increases visibility of total VOC exposure compared to traditional manual canister capture methods. Here, maximum VOC levels detected by triggered sampling are shown to be roughly 2 orders of magnitude greater than weekly sampling. To conclude, the APIS Ajax solution provides similar detection of pollutants as much more expensive equipment and provides useful context for finding sources. This project has led to new understanding of intense, shorter-term plumes that can release significant amounts of air toxics and ozone precursors, often without methane in the plume composition. These discoveries have in part led to Colorado regulators now requiring extensive monitoring systems at all new oil and gas developments. A special thanks to Brian Terry at Ajax and Adam Crandall of APIS for our ongoing project field and technical support and photos used in this presentation. Also thanks to our research partners at Colorado State University and to the City of Broomfield and the air quality team for their amazing support and interest. The latest monitoring network map can be viewed online with Google Earth at tinyurl.com/BroomfieldAQ. Public project data graphs, VOC tracking map, quarterly reports to Broomfield City Government, and more project information can be found at broomfield.ajax-analytics.com. Thank you for this opportunity to share our findings and new developments. Please contact us for more information and to find out how you can use this technology for your own air monitoring projects. You can phone us at 833-APIS-AIR, That's 833-274-7247, or email us at info@apis-aq.com.